So in this section, we're going to be looking at how to go from standard form back to vertex form. We've been doing a lot of work with vertex form. The last couple of days we've been focusing on standard form, but now we need to know how to go from standard form back to vertex form. In this process, we were going to be using a method called completing the square. This is the method that gets us from standard form to vertex form. So we need to understand what we mean by square. Well, a square is just basically, if I have an area, it's a square if the two sides have identical factors. Length times width is 25. 11 is not a square. 11 by 1 is not a square. X to the fourth is, because I can make two identical factors. X cubed is not. Let's focus on quadratics, because that's what we're focusing on in this chapter, quadratic functions. So in a quadratic, what makes it a perfect square? If I can factor it and make two identical factors. Two numbers that multiply to give 9 and add to give -6 are -3 and -3, which we can write as a product of two identical factors, the square of the two factors. Same thing with this one, x plus 4 by x plus 4. So these two are square trinomials. This one isn't because of that -1. How can my two factors be the same when that's negative? That's impossible, so not a square. And this one isn't as well because this can only factor into a GCF of x multiplied by x minus 4. So one side is 4 less than the other, so not a square. So those are the only two quadratic squares we have here. So now we're going to look at, okay, so if we're looking at quadratics, how can we complete it to make this a perfect square trinomial? What number makes it a perfect square trinomial? And if I look back here, remember the two numbers that multiply to give 9 had to be 3 and 3. And since they add to give -6, they had to be -3 and -3, right? To get 16, it was 4 and 4, and 2 4s make 8. So you'll notice if I cut that in half, I get one of the factors. If I cut 8 in half, I get one of the factors. And the last number is the square, the last number multiplied by itself, which is the same. So how can I complete this? Well, we did the first one. We know it's 16 because half of 8 is 4, and square that 4, I get 16. Same thing here. Take your 2. 2 divided by 2 is 1. 1 squared is 1. So if I was to factor this, I now know that two identical factors are x plus 1 times x plus 1. If I was to FOIL this out, I would end back up here. Expand and simplify ends back up here. And again, a reminder, you can always write this like that. Since those are the same, you can write it as a square of a binomial. This one here, I take my -10, I divide it by 2, I get -5. -5 squared is positive 25. You'll also notice when you complete the square, it's always going to be positive because two identical factors have to be positive. So we get x minus 5 times x minus 5, which is x minus 5 squared, which I could write like that, right? Sometimes when you try to complete the square, it doesn't work out nicely and you get these nice numbers. You get fractions, but that's okay. So you have your -1. You take half of your -1, which leaves you -1/2, and then you square it and you get 1/4. So you're adding 1/4 onto the end, and if I was to factor this, you would look like this, right? Which is x minus 1/2 squared. Okay, so sometimes you will have fractions. So sometimes when we want to complete the square, we have a number already there, a constant term there. But that constant term does not make a perfect square trinomial. So I want a perfect square trinomial out of this, but I don't want that 13 to be part of it. So what I'm going to do is I'm going to complete the square, but I'm only going to complete the square using these two. I'm going to kind of ignore the 13. I'm going to push it aside. So I'll use brackets to show you that I've pushed it aside and it's not part of it's still there, but it's not part of my thought process. So to complete the square, I take my -6, I divide it by 2, I get -3. and then I square my -3 and get +9. But I can't just leave it like that. Up there I did. I changed the expression. I created a perfect square trinomial. I want this expression and this expression to be the same. So if I add 9 there, I better subtract 9 there. Now I can put an equal sign between these two, right? These two are now equal. And so now I can rewrite this. Maybe I'll write it below so it looks better here. So now I can rewrite this as this factored. So I'm going to get x minus 3 times x minus 3, which I can write like that. And now I can combine those terms. And what you're starting to see is this standard form, if it was y equals, if it was a quadratic function, would be the same as this standard, or sort of same as this, but this is in vertex form. So we've already started the process of converting it to vertex form. Let's try another. So this one's going to be x squared plus 8x. Remember, ignore the constant term. If it was a term that created a perfect square trinomial, I wouldn't do any of this. I would just factor it, right? But -3 does not create a perfect square trinomial. So I take my 8, divide by 2, get 4. 4 squared is 16. That's my perfect square, but I have to subtract 16 to balance it out. So now I have my factored form of that. 2 of those is the same as that perfect square trinomial, and that's -19. Again, working into vertex form from standard form. You'll also notice that I've only factored it this way. I've only completed the square when my x squared is 1. This rule only works when my x squared is 1. If it wasn't a 1, then I'd be foiling out numbers that are like 2x and 3x, and this wouldn't work. So only complete the square when you have a 1x squared. So what you can see is what we've done right here, the same question, but now in terms of a quadratic function. I have completed the square, and now I know my vertex is 3, 4. I can graph this. I know my minimum output of 4, and it's a minimum because it opens up, and my a is positive. Same thing down here. Everything's the same as we did before, but I just have my y equals. It's now a function, right? And I now completed the square. I know x plus 4, meaning -4 is my vertex. -4 is x, and -4 produces -19. It's another minimum because a is positive. So -19 is my minimum of this quadratic function. All right? But what happens, what happens when my a isn't 1? Well, remember, I said you can only complete the square when it's a 1x squared. So we need to deal with that first. So again, that -25, always push it aside. Just focus on those two. The -25 just tags along, and at the very end, we combine like terms at the end with the constants. So in this one, before I can complete the square, I need it to be a 1x squared. So I need to factor the 3 to get the 1x squared out of those two terms. Factoring just means to divide out, right? So I'm dividing that out of the first two terms. I leave a space so I can complete the square, and I push my -25 aside. I did not factor it out of that one. Okay? Now to complete the square, I divide that by 2 and square it. You'll always get a positive, right? Now, this is the tricky part. I can't just put -4 there because I did not add 4. I added 4 inside the brackets, but if I was to distribute that 3 back in, what did I really add? I really added 12. I added 3 by 4. So I really have to -12 to keep it the same. So that's where you have to be careful when the a is not 1. So what do I have here? I have y equals 3 bracket this perfect square trinomial, factors into that, and that combines to -37. So I have a vertex of 2, -37. I know it opens up, so therefore a is a min because it opens up, or a is positive, however you want to mention that. This one, same thing. A is not 1, but a is also negative. So let's practice another one. So we have y equals, and again, we have to have that 1x squared to be able to complete the square. So we're going to factor the negative 4 out. When I divide by negative 4 in the first term, I'm left with x squared. When I divide by negative 4 in the second term, I get negative 2x. Be very careful with your signs when you're dividing out a negative. Leave a space, and that minus 15 gets pushed outside. Complete the square. When I complete the square, I just look at this number, divide by 2, I get negative 1. Negative 1 squared is 1. Okay, so now that I've completed the square there, let's change that color to 1, I always have to say, what did I really add? I added negative 4. So to balance it out, I have to put positive 4 out here. So be very, very careful. So now I have y equals negative 4, factor this, and I get my vertex form. My vertex is 1 comma negative 11. And this time, my negative 11 is my max. And why is it a max? Because my a is negative, so it opens down. So it's at a maximum output. When I input 1, I get a maximum of negative 11. Sometimes, and I might run out of time here. Oh no, I think I'm doing okay. We'll try to work through this one. Sometimes when you try to factor the 6 out of the 27, it just doesn't work out evenly, and you have to work in fractions or decimals. You have a choice. You can work in decimals if your decimals are terminating, but you should work in fractions if you get like 1/3 or 1/7 and you get repeating decimals. So let's practice in fractions so we get that extra practice. If it's a decimal, then you can do that no problem on your own. So let's divide the 6 out. And so when I divide that out, I get 27 over 6. It doesn't go evenly, so reducing it down, I get, what do I get? 9 over 2, or 4.5 if you're working in decimals. Leave my space and push the 13 aside. Now, how do I complete the square? Well, if it was decimals, you just go 4.5 divided by 2 and then square it. If it's in fraction, how do you do 9 over 2 divided by 2? Well, you're just taking a half of it, right? And so you have 9 over 4. That's taking a half of 9 over 2, and then you want to square it. You're going to get 81 over 16. So that's what you really added, 81 over 6. Or not really, that's completing the square, sorry. So you completed the square. But you can't just minus 81 over 16 because, like I said, you need to always check what you've added. What did you add? I added 6 by 81 over 16. And so when you multiply that, what do you get? Divide by 2, you get 81 times 3. Calculate this out really quick. 81 times 3, which is 243 over 8. And so you've really added that, so you have to subtract 243 over 8. So to combine these two, you just need a common denominator, right? So you times by 8. You take your 13 times by 8, and you get 104. And so 104 minus 243 gives you, and we're going to write it over here, negative 139 over 8. And then now, I'm just working backwards this time. This factors into two numbers that multiply to give this and add to give this are 9 over 4, right? X, right? Squared. Multiply that out twice, you would get that. And the 6 is still there. Okay, unless I made a silly arithmetic error somewhere, which might be possible in my speed here, but that should be vertex form, in which my x is negative 9 over 4, right? And my q, or my y, I should say it, is negative 139 over 8. And again, if you worked in decimals, you can just check it that way as well. This opens up, so A is a, whoops, not a mix, it's a min. Get the idea. All right, do we have time for one more? I don't think so, but we could do this really, really fast if we can try. I might run out of time, but don't forget there's a negative out front, so sometimes you're just factoring out a negative and it becomes positive, right? And then you want to complete the square, so you want to take what, a half of that, right? And then you want to square it, so you're going to get 1 over 16 squared, which is 256. So to complete the square, you're going to write plus 1 over 256, but you really added negative 1 over 256, so you have to add positive 1 over 256. And so I think I've got 10 seconds left. We'll go speed a half of that, make that a plus, and put my squaring in, and I think I just made it in time. There you go, completing the square.